So in this video, we're going to talk about vector addition. Suppose three vectors are given, vector A which has a magnitude of 345 meters and a direction of 23 degrees northwest. Vector B which has a magnitude of 175 meters and a direction of 46 degrees west of south, and a vector C, which has a magnitude of 250 meters and a direction of 87 degrees southeast. And we are asked to find the resultant vector. Let's first illustrate the given vectors using the head to tail method. First, we have 23 degrees northwest. It means we are drawing the angle from north going to west, and it has a magnitude of 345 meters. From the head of the first vector, let us draw the second vector with a direction of 46 degrees west of south and a magnitude of 175 meters. And again, from the head of second vector, let us draw the third vector on the direction of 87 degrees southeast and a magnitude of 215 meters. And now we can visualize our resultant vector for solving it. And now we are set to find the magnitude and the direction of our resultant vector. And to do that, we first need to find the x and y components of each vectors given. For the first vector, vector A, let us first illustrate the given vector, which is 23 degrees northwest and 345 meters magnitude, and let us find its x and y component. Since the x component is on the opposite side of the angle, let us use saw from the trigonometric identities SOHCAHTOA. And for the y component, since it is on the adjacent side of the angle, we're going to use ka. To solve for the x component, let's first write the equation of saw, which is sine theta is equal to opposite over hypotenuse. And we know that the opposite here is our x component, and the hypotenuse is the given magnitude, which is 345 meters, and the theta is 23 degrees. So rewriting the equation, now we have sine 23 degrees is equal to x over 345 meters. Multiplying both sides by 345 meters, we're going to cancel out 345 meters on the right side. And we are left with the equation x is equal to 345 meters multiplied by sine 23 degrees. And that will give us 134.80 meters. And for the y component, let us write the equation of ka, which is cosine theta is equal to the adjacent over hypotenuse. And we know that our hypotenuse is 345 meters and our adjacent is our y component, and our theta is the given theta, which is 23 degrees. And rewriting the equation, we have cosine 23 degrees is equal to y over 345 meters. And let's multiply 345 meters both sides to cancel out the 345 meters on the right side. And now we are left with the equation y is equal to 345 meters multiplied by cosine 23 degrees. And that will give us 317.57 meters. And let's take note the x and y components of the vector A that we find. And we also need to take note about the direction of our components. Since the given vector is going northwest, so our x component must be going to west. And same goes to our y component. Since the given vector is going northwest, our y component should be going north. For the second vector, vector v, let us again draw the illustration first before finding its x and y components. Since our y component here is the adjacent, let us use ka. And since our x is on the opposite, we're going to use so. To solve for the value of y, let's write the equation so, which is sine theta is equal to the opposite over hypotenuse. And our opposite here is the x because it is the opposite side of the angle. And our hypotenuse is the given 175 meter magnitude. And the theta here is the given theta, which is 46 degrees. Rewriting the equation, now we have sine 46 degrees is equal to x over 175 meters. Let's multiply 175 meters both sides to cancel out the 175 meters on the right side. And now we are left with the equation x is equal to 175 meters multiplied by sine 46 degrees. And that will give us 125.88 meters. And now to solve for the y component, let's write cosine theta is equals to adjacent over opposite. And our adjacent here is our y component and the opposite is the given 175 meters. And the theta is 46 degrees. Rewriting the equation, now we have 46 degrees is equal to y over 175 meters. Let us again multiply both sides with 175 meters to cancel out the 175 meters on the right side. And we are left now with 175 multiplied by cosine 46 degrees. And that will give us 121.57 meters. Let us again take note the x and y components and the direction that we solved. Since the given vector is going west of south, our x component must be going to west and our y component must be going to south. Now, let's start finding the x and y components of the third vector given. And let's start by illustrating the vector. And again, since our y component here is the adjacent side of the angle, let us use ka. And since x is the in the opposite side of the angle, let us use so. And to solve for the x component, let us write the equation sine theta is equal to opposite over hypotenuse. And the opposite here is our x component, and the hypotenuse is 250 meters, and the given theta is 87 degrees. Rewriting the equation, we have sine 87 degree is equal to x over 250 meters, multiplying 250 meters both sides, and we're going to cancel out 250 on the right side. Now we are left with x is equal to 250 meter multiplied by sine 87 degrees. And that give us 249.66 meters. To solve for y components, let us write the equation cosine theta is equal to adjacent over hypotenuse. The adjacent here is the y component, and the hypotenuse is equal to 250 meters, and the given theta is equal to 87 degree. Rewriting the equation, we have cosine 87 degrees is equal to y over 250 meters, multiplying 250 meters both sides, we cancel out the 250 meters on the right. And we are left with y is equal to 250 meters multiplied by cosine 87 degrees. And now we are left with 13.08 meters. Now let us again take note the x and y components that we solved. And since the given vector direction is southeast, our y component must be going south and our x component must be going east. After we get all the x and y components of each given vector, let us find the summation of x components and y components. For the x component, we have 134.80 meters plus 125.88 meters minus 249 minus 0.66 meters. And we are subtracting here the 249.66 meters since it is going on the opposite direction than the other two x component vectors. I can also write this as summation of x is equals to 249.66 meters minus 134.80 meters minus 125.88 meters, as long as opposing direction should has an opposing sign. But I would like to deal with the first equation so that I won't be dealing with negative numbers. But you can use any of these two equations. And now we have the summation of x equal to 11.02 meters. And when it comes to its direction, it should be going to west since west has a greater magnitude than a vector going to east. Same goes to our summation of y. Let's just add all the y components that we solved. It is 317.57 meters minus 121.57 meters minus 13.08 meters. And let us always take note that opposing direction should have an opposing sign. And now we have 182.92 meters going to north for our y component. And since we already have our x component and y components of the three given vectors, let's take note of that. Let us now illustrate the x and y vector components that we solved using the head-to-tail method so that we can easily solve the resultant vector. Since they form a right triangle and we are given the two side lengths, we can now use the Pythagorean theorem, which is c squared is equal to a squared plus b squared, where a and b can be x and y components and c is our resultant vector. And we have now the equation resultant vector squared is equal to 11.02 meter squared plus 182.92 meters squared. And that will give us the value of resultant vector squared, which is 33,581.1668 meters squared. And to find the value of the magnitude of resultant vector, let's get its square root, and we have now the 183.25 meters. And to find its direction, let us use the equation TOA from the trigonometric identity SOHCAHTOA, which is tangent theta is equal to opposite over adjacent. And now we have equation tangent theta is equal to 11.02 meters since it is in the opposite side of the angle over 182.92 meters because it is on the adjacent side of the angle. And now to get the value of theta, let's get the arctangent of the right side of our equation. And that give us the value of 3.45 degrees. And for its direction, it should be going northwest. And that is based on our illustration above. And with that, we already found the resultant vector with a magnitude of 183.25 meters with a direction of 3.45 degrees going northwest.